Okay. Thank you very much, and thank you everybody for joining us today. I know it's the end of your working day. We are joining you from Waterloo in Ontario, near Toronto. And what I'm going to do is give a little bit of an introduction to who Maplesoft is and why we are involved in the world of systems engineering, and then we'll give you a bit of an introduction to the Excel-based tool that we've been working on to help in broadening the reach of the systems engineering process, but basically to try and get non-systems engineers to engage more effectively with the MBSE process. I'm joined by Bharani Mohan, who's our product manager for Maple MBSE, and he's set up to give you a live demonstration of the tool, just walk you through the workflow between Maple MBSE and, in this particular case, through Teamwork Cloud and Cameo Systems Modeler. Okay, so to just give you a little bit of an introduction to Maplesoft, we've been around over 30 years as the developer of mathematical-based tools for many different applications, primarily in we've come out of the academic market, but we've been developing engineering tools that sort of fit into the whole systems design process in three specific areas. One is calculation management. So our flagship product is Maple. It's a very powerful symbolic mathematical tool used by many different engineers and scientists for developing analyses for specific technical problems. Actually, just last week, we just introduced a new variant of Maple that's directly targeting the engineering calculation world. So it's a somewhat different user interface. The product is called Maple Flow, and if you'd like to find out a bit more about that, you can find that on our website. About 10 years ago, we introduced Maple Sim, which builds on our symbolic capabilities to create multi-domain dynamic models of systems. So the idea of the tools to create early-stage prototypes in order to understand the dynamic behavior of complex systems, so running simulations and so forth. And then relatively recently, and I'll explain why we got involved in the systems engineering side of things, we introduced a product called Maple MBSE. So this is our third year of promoting the tool, and this will be the focus of this particular session. Of course, over the years we've amassed a lot of experience with many different customers, and this is just a snapshot of the customers that we have worked with. But one of the things that is in common with all of them is that they are large, complex organizations developing large, complex products and systems that require many different groups to work together to come up with a successful product. And that's really why we got very much involved in this. So in terms of our activities and with our customers, very much involved in the design development process through the V cycle, and we have been heavily involved in the early stages of that process. So our traditional customers, the people that are using our analysis and simulation tools, they are typically creating some kind of early stage prototype of the system in order to be able to verify that that proposed system is going to comply with the requirements that have been defined within the architectural models that have been typically developed by the systems engineers. So there's very much a communication dynamic that's going on between these two groups, and this is where we were starting to see some challenges. Obviously, the first challenge is just how you can introduce, or how you integrate the information that's in one repository, if you like, with information that is elsewhere in the process. But I think the biggest problem that we are seeing is that it's very much a human problem. It's how does this group effectively communicate with this group, and this is where we're seeing the challenge. And we're not the only ones that are seeing this. This is borne out by several studies that have come to light in recent years. This particular study was produced by SimData, who are an industrial analyst primarily in the US market. But this was conducted in collaboration with ANSYS and INCOSE. And fundamentally, what we're seeing here is that the barriers to a successful implementation of systems engineering is much more about the culture, training, education, organization, and fundamentally it's about people and processes. Within Europe, we see a very similar picture. This is another study that was produced by Bruhl and Chami, which really highlights that that there is almost a disconnect within the various stakeholders in terms of adoption, or getting in the way of adoption of a successful MBSE process. And then just from our own experience, when we've been working with within these projects, what we would typically see is the systems engineer would be the person that would be creating a systems model as the authoritative source of truth. And then, you have the many different stakeholders who need to acquire information from that source of truth, do their own work with it, and then take the results of their work and submit this back to the systems engineer, who would then update the results of that work back into the systems model, and then basically developing and expanding the systems model based on the information that's coming in from the various stakeholders within the project. But this is a very human and very ad hoc process. Misinterpretations, miscommunications, errors start to creep in. There's a lot of unnecessary rework and design reviews to try and figure out where those errors are coming in, and then largely it's just down to that sort of ad hoc process in terms of transmitting the information. So we see this very much as a real friction point in the whole process, and not only does this cause delays in the projects or more costs, it actually erodes confidence in the process by all the other stakeholders. So what we're proposing is, well, rather than go through that ad hoc process, why not give each of the stakeholders direct access to the systems model in an appropriate way, that they can take views that have been created within the systems model that are appropriate to the tasks that they are performing, and then any changes that they make in those designs from the results of the work that they do, they can then submit those changes directly back into the systems model. However, we can't expect them to use tools like Cameo or Rhapsody to do this kind of work, but give them a tool that everybody's familiar with, and that is Excel. So what this what the net result of this means is that the stakeholders can work in a very familiar environment, make the changes that they need to make, and then submit those changes back into the systems model. Now the systems model becomes the source of information for performing those design reviews. So now we have a much smoother way where the information that is being fed into the systems model in the way that the subject matter experts or any other stakeholders intended it to be, but it's structured in a consistent way for the systems engineers. And now this can be the way for those stakeholders to work much more smoothly and collaborate more smoothly with the systems engineer. But not only that, this actually provides a way for all the other various stakeholders to collaborate with each other. So now the information can be served up in an appropriate way for various tasks with the systems model through collaboration throughout the whole design process. So, we feel that this is, but first of all, this is the value proposition. We feel this is a much more appropriate way of being able to smooth out those frictions that are typically found in the systems process. So just to talk about a little bit, well, what is Maple MBSE? And and it's kind of important for us to talk about this because what we are offering is not like Excel file import or export. This is actually a very tight integration with the systems model. So you can create specific views for the tasks in Excel, so it's familiar to the end user. Any changes can then be directly committed to the systems model, and any changes that are made within the systems model, those updates can be then synchronized back into the view that each person is using. And we'll see this in a bit more detail when Broadening goes through the workflow. These are highly customizable for creating task-specific views and analyses. And again, we'll talk about specific applications a little later. And at the moment, we have integration with pretty much all the key some of the key platforms. It's systems engineering platforms. Rhapsody, Magic Draw through Teamwork Cloud, and Capella, and we'll be focusing on the use of the Magic toolchain in this particular session. So, at a very high level, what Maple MBSE brings to the whole operation is this ability to be able to collaborate very effectively across the whole organization. This allows all the various different stakeholders to collaborate and engage with the systems engineering process in a much more appropriate way. People get up to speed very quickly. The tools that are used, nobody has to worry about SysML, for example, in order to make any changes to the model. All of that is handled by the Maple MBSE backend, and fundamentally, this reduces that friction, reduces the likelihood of errors being introduced, and project costs and so forth. And just to wrap up on this Maple MBSE is also a very open platform. It's not a black box. The backend has APIs that allow the integration of, well, first of all, the customization of different views and models, but also integration of information from different sources within your PLM platform or whatever design platform you're using. And if you want to find out more, you can go to our website, maplembse.com, to find out to get more details on that. So that's basically my high-level description of Maple MBSE, and why we've been getting involved in this. Why we think it's important for people like yourselves to at least understand what we bring to the table with this tool. So with that, I'm going to pass it over to Broadening to take you through the workflow.
Yeah, thank you, Paul. Okay, I should be able to see my screen now. So for today's demo, what I'm going to do is I'm going to launch a Maple MBSE configuration file. So this is the file that user who is going to interact with Excel is going to launch. We are going to connect to a model in Teamwork Cloud server, bring that model, make some changes in Maple MBSE and save it back. And for the demo, I'm using a very simple model, but it's very effective to show the workflow of how a user can add or edit some information and save it to Teamwork Cloud. So I'm going to double click on the configuration file. So when you double click on that configuration file, you're going to see Excel to pop up, and then it's going to ask me to provide my credentials to connect with the server. So since today we are seeing our demo based on Cameo and Teamwork Cloud server, we are going to see the screen to log into Teamwork Cloud. And to give you a bit of idea of what the configuration file is, the configuration file is going to have the mapping information between how you want the models from the SysML model and transform it into tables that has to be displayed in Excel. So that's what MapleMBSE handles. The SysML models is got by MapleMBSE, it is transformed into tables. So here I have my login screen, and I have the option of selecting the server that I want to connect with, my username and the password. So here, say in case of Teamwork Cloud, if the Teamwork Cloud server administrator has given you access to certain projects and not the list of all the projects that's within the server, you'll be able to see only those restricted scopes. So you can actually control uh, in place of the end user, like what are the projects that you need to expose to the user. And so once the credentials are valid, you'll be able to see a list of projects. I'm going to work with the TWC sample. So in this specific username, I was able to see the list of projects that's available in the server. But again, like I mentioned, this could be controlled. And again, we have the option to select the branch that we want to work with. And the option of save setting, it's going to save the previous login information. So I'm going to work with the default branch, so that's trunk. So by default, it's always going to select the trunk branch. And once I click OK now, what MapleMBSE will do is it's going to establish that connection with Teamwork Cloud and bring the information from the SysML model and display it into Excel. So this worksheet is just a template that I created that is not related to the Teamwork Cloud. This is just to explain how or what is happening on the MapleMBSE background when I click on the file and select a model. So I already give you a brief of what the configuration file is. So in our case, we selected the Teamwork Cloud server and we selected a model from it. And based on this configuration file, what MapleMBSE will do is it's going to take the scope that's defined. For example, say if you're having different uh, systems and subsystems, and you want the user who is going to interact with MapleMBSE to open only a specific part of a subsystem, like just the behavior of a subsystem, etc. So based on this, you would have already defined the scope inside the SysML model, and now that information is going to be displayed to the user in tables. So once MapleMBSE gets this information, is going to transform it into tables, and this table is shown in Excel. So it's not just exporting the information from the Teamwork Cloud and then when the user makes changes, it's importing. There is this connection that's maintained within the server and the Excel frontend. So you make any changes, you are actually making change in the SysML elements. And once you save it, it's going to save these changes to the model, and you'll be able to see how your changes to be reflected as SysML elements itself if you open the model with Cameo or Magic. And you can consider each of these worksheets as like a view into the system model. Like these are the list of packages in the model. These are the requirements that shows derived relation, etc. So just to show a comparison between the model that we have opened here and then Cameo. So on the top of this Excel, you can see that I'm connected to the server, the project that I've connected with, the branch, and the username. And I'm going to open the same model here in Cameo. You can see that we are again connected to the same project and the server. To show a comparison between the kind of elements that we see here in MapleMBSE and Cameo, we're going to see the same list of requirements, the blocks that are available in the model as components. So you are able to see the same information here. So for a user who's going to work with MapleMBSE interface, say, I want to add a new requirement here called R06, and I want to call this requirement as performance requirement. And the specification for this is something like the car should reach 60 miles per hour in, say, 6 seconds. So something like this. I have just added a new requirement, given it an ID, the name, and the specification. So if I go to the other worksheet, you can see this new requirement has already been created because the changes that you're going to make is going to propagate to all the other worksheet and also within the model. And to create a derived relation, all I have to do is add a check between the intersecting row and cell. Say I want to create a derived relation between the new requirement that I added, R06 and R05. So this would add a new derived relation. So if I go back to the previous worksheet, you can see this new row has been added automatically, showing that R06 is derived from requirement R05. And here we are seeing the actors from the model. Say I want to create an actor for performing maintenance. So someone called maintenance technician. So the use case for this user is going to be to perform maintenance. And the actor that's responsible for this use case is the maintenance technician. So since we are bringing the information from the SysML model and displaying it here in Excel, you can use the Excel functionalities like you can use copy paste, data validation, data filtering. You can use your own macros, formulas, etc. And this worksheet here, it's a view of the components from the model. So I see a list of components like blocks in SysML terms and their subcomponents. So say I want to create a new component called gearbox A, and I'm going to tell that gearbox A is a part of gearbox. So I'm using just copy paste here, and this is going to be gearbox A. So you can see that I created a new relation here, and the additional row was added because gearbox is already owned by dual clutch transmission. So that's why the complete hierarchy was added in the new row. That dual clutch transmission holds gearbox, which in turn holds the gearbox A. The other worksheet here, this is the matrix that displays the satisfy relation between the blocks and the requirements. So we have the new block gearbox A that we created and the performance requirement. Say that this new block called gearbox A is going to satisfy my requirement R06. So I'm just going to add a X here, means that I have added a satisfy relation. And if you have noticed that once I added this X, I was able to remove the conditional formatting here. Again, like when there are large amount of data, I could include these conditional formatting to see the requirements that do not have a certain specification, like it is not satisfied or derived. So example, I'll just add one relation here, like the dual clutch transmission and I performance DTC. So you can see that the highlight was added. So this is all purely Excel. So this is not what Maple MBSE is. This highlight, the conditional formatting is all done by Excel. But the entries that you're adding, like the relations, the components, these are what Maple MBSE handles, and this is what will be saved to the model. And the final worksheet, the satisfy worksheet, is the same information that you saw here in Matrix. The only difference here is you are seeing it as a table format instead of a matrix. So till now I've added few elements into the model, and all my changes are still local. So if I go back to Cameo before saving my changes, I'm just going to update my logs information. So you can see the moment I start editing in Maple MBSE, it's going to acquire logs for that specific part of the model. So since we added gearbox A and said that it's a part for gearbox, this specific component is locked. And similarly, we added new component into the structures package, same way with the requirements and use case. So what this ensures is it's going to ensure that you do not have any conflict. when there are different users collaborating to work on the same project. So if a user from Magic Draw or Cameo system locks an element or locks a package to edit, and the user from Maple MBSE tries to edit the element, you are going to see unable to lock the model element. Again, this is to prevent the conflict of users deleting or overwriting each other's changes. And same way, this is with Maple MBSE. Since I made these changes to the respective packages, you are seeing the locks acquired automatically in the model. So now what I'm going to do is I'm going to go ahead and save my changes. And you can also notice that here we are at revision 79, which is consistent with the revision here in Cameo. So every time you make your changes and commit to the server, you're going to go to a new revision. So again, the revision management is consistent with how you're going to work with Cameo or Magic Draw. And the other functionalities that Maple MBSE introduces is inside the add-ins, like in the ribbon, you will have an add-ins button that's going to have certain functionalities like importing if you want to import large amount of data, or if you want to export this Maple MBSE worksheet into a simple Excel. These are the options that would be helpful. So now I'm going to double click on the save button. I'll see commit to Teamwork Cloud dialog box, and I'm going to add a message as added new requirement. And click OK. So now you can see that I moved to the new revision, and to see the latest changes, I'm going to update my project here. And you can also notice that once the update is done, the logs will be removed. So the user doesn't need to worry about acquiring the logs or releasing the logs once they have completed their edit. Maple MBSE will handle this automatically. So here we can see the requirement R06 we added, the gearbox A. And I'm going to just drag and drop these elements here. We had created this gearbox A. Then we created the requirement R06. And we also added actor and then use case. So you can see now here that the new additions that we made with the Maple MBSE's Excel interface, like we created an actor called maintenance technician. You can see them, these model elements being reflected as SML elements itself, like the maintenance technician as an association, and that's to perform maintenance. And same way, gearbox as a composition relation to gearbox A. And we also added a satisfy relation between the gearbox A to the performance requirement, and that's shown here. Similarly, we said that the requirement R06 is derived from R05, and we see the derived relation here. And if you actually notice, with the Maple MBSE worksheet, specifically say within this blocks tree worksheet, we do not make any decision of to think if it should be an association or if it should be a composition or an aggregation with direction or without direction. So all of these complexity of what SysML offers has been hidden here. So for a user who is not familiar with the modeling tool and the modeling language, for him all that concerns is whatever new entries to be added to the column C, like this will be added as a component in the end user term. And if it's being added to the second level, this is going to become the subcomponent. So these are the components, these are the subcomponents, and that's all. And same way here, like this could be between this could even reflect, example, the connectors between the different paths. So for the end user, and what an X is going to reflect is that there is a connection that's going from a certain part to a different subsystem and its path. So these are the complexity, or this is how end user is going to interrupt the Excel, and he's going to edit it. But here you can see that they all will be reflected as SML elements, and you can use your own profile. You can extend the existing SysML profile the view or whatever the end user is going to see, it's all going to be again just Excel. And like Paul mentioned in the last slide of his, the views that you are seeing here, they are not black box. So you can completely customize the views. You can completely customize the configuration file to fit to different project structures, or your if you have a different modeling rule or different profiles, you can completely customize it. You can connect to that model. You can work with the same way. And for the end user, he's not going to know any difference because he's going to interact with the same view in Excel, irrespective of different projects. If it has different profile, that's not going to be his concern. For him, he's going to interact just into tables. And this is the value proposition that Maple MBSE offers, that it's going to hide the complexity. You can involve many stakeholders who are not familiar with SysML. They all can work on the same model at the same time. And you can manage which part of the model that the end user is going to work with. You can define the scope. You can define like, I want to expose just the a specific subsystem or a component of the system to perform certain analysis, like say a safety analysis, or just as a review and add some comments back to the model. So you can define the scope completely with Maple MBSE, and you can see here, like it's easy to manage different users. It's easy to also manage the change management, because every time a commit is done, it becomes a revision. So you can easily review what changes were added and where these changes were added into the model. So this is what Maple MBSE is, and I'm going to pass it back to Paul.
Okay, thanks a lot, Bernie. Okay, yeah, I'll just share my screen again. Here we go. So I've just got a couple of slides just to wrap up, and then we can open the line for questions. So many times with the question is asked is, well, what is this good for? I mean, you know, obviously the high level answer is that anything where you're using Excel for doing these kinds of tasks is probably a good candidate for integration with the systems model through Maple MBSE. But you know, these are the kinds of applications that we typically get involved in: ICDs, variant management, safety analysis, FMEA, all sorts of different trade-off analysis, because you can still use Excel as a tool for trying different parameters and making changes to the systems models, and of course variant management as well. You know, these are typically the kinds of activities where Excel is typically used as a tool in those things. So you know, at a sort of pretty high level, you know, anything that requires the integration of large quantities of information. Equipment, this is a good example. Typically they'll be represented as a flat file with some kind of implied hierarchical structure. We can use Maple MBSE to not only bring the equipment listings, but also to bring in that structure, so that when it goes into the systems models, the subsystems and subsystems are actually reflected in that. Tasks that are typically performed using spreadsheets, as I mentioned: safety analysis, FMEA, energy, maths, roll-ups, cost budgets, those kinds of activities. Tasks that require specialist skills and knowledge, you know, the SMEs, the subject matter experts. Typically, you know, they're not masters of tools like Cameo or Rhapsody, but the information that is in their heads or in their activities has to be brought in. Things like, you know, breaking down requirements and so forth. It's very easy to use Maple MBSE as a tool for doing that kind of work. And then really as a tool for the systems engineer, as a way of being able to do things like impact studies, design structure matrix analysis, traceability. You know, these are the kinds of activities that a systems engineer may even typically do in an Excel spreadsheet, and now you can do it with it completely integrated with the systems model. And again, if you have any questions on those applications, we'll be happy to talk about that in the Q&A. So for me I just want to wrap up. Then thank you for your time and attention. Really, what we're providing here is a Excel-based tool that allows systems engineering environment to be integrated. All the information can be integrated throughout the design cycle. In many respects, it offers the power to democratize the process, give the non-systems engineering stakeholders a more closer engagement with the systems models without having to know anything about SysML. And certainly in the projects that we've been involved in over the last 3 years, it's been proven to accelerate the system definition process by just simplifying that process. We don't really have time to go into specific case studies in here, but if you go to our website, MBSE.com, you'll find there's a fairly detailed case study from a project we were involved with at Nissan in Japan, and also some sort of case studies and use cases that have been demonstrated by NASA, particularly at the Jet Propulsion Laboratory, JPL. Just to give a sense of where the value can be, and certainly to help you to define the sort of return on investment that's required in order to engage or to adopt Maple MBSE within your processes. So with that, thank you for your time and attention, and thank you, Christian, for organizing this. We're ready for any questions.
Thanks a lot for the inside view to Maplesoft. Yeah, everyone is asked to speak up. I would like to start the question and answer round with the first question, if I may. You talked about barriers, culture, and people, which really you speak up to my heart. But I know you are a tool vendor, but if you have the chance to, let's say, have an impact on people and processes and culture, what would you do if somebody is asking you, okay, we like your tool, but I guess we have a problem concerning people, culture, barriers. What would be the approach? Introducing Maplesoft.
Yes,
but
yeah.
If you just look at a broader scope of things.
Yeah, and I do understand the question and the challenge. I mean, certainly, the biggest challenge that we face is that nobody wants to disrupt the process, even though this might be a better way of doing it. And of course, there's a lot of convincing that needs to be done. So our typical approach to doing this is to start with a very simple pilot project, and create something where where the scope is very very narrow but valuable.
Quick wins, to have some quick wins to show the potential of this approach.
Yeah. Okay. Yeah, and then from that, to start building up from that point. So it is a process, and certainly we don't expect our customers to just buy hundreds of licenses and expect they're going to be able to have a successful time implementing it. It is a
long journey.
Long journey, yeah, to make this happen. But the impact has to be high right at the beginning.
Okay, Rani, you showed just block diagrams, requirements diagrams, but I saw on the wrap-up slide that you can handle internal block diagrams, you can do activity diagrams, you can do functional decomposition, all the stuff. You showed some, let's say, two basic things of structure and requirements of SysML, but especially behavior is in the toolbox of Maplesoft.
Yeah, so as of now, what we have support for is to 8 SysML diagrams. So the only support that we don't have is for the sequence diagram.
Okay.
You can use Maple MBSE to view the contents of the sequence diagram, but you cannot actually make any changes to the sequence diagram. But
Okay.
other than that, the behavior diagrams, like say the use cases, the state machines and activity diagrams, you can interact with in any components that goes into the diagram. You can create it, you can edit it, and get it back to the model.
Also if I ask an engineer who is not familiar with SysML and he's capable of thinking in function and he's doing a functional decomposition, this can be returned to Cameo by using
Yes.
Excel. Okay.
Yep.
Okay. So thanks a lot. That was my part. Feel free to ask any question if you like. Please mention your name in your company if you like before you raise the question.
My name is Johanna Schaffner. I'm coming from AVL in Germany.
Oh.
And my question goes in the same direction of Christian's. So it's not just an interface for connecting requirements and blocks and so on, but it would also be a help for systems engineer colleagues who are not so familiar with SysML, maybe as a sort of help to start setting up models?
Absolutely, yes. Yeah, I think anybody who anybody who needs to contribute to the systems model. In fact, it may be even for a systems engineer to be able to start with a tabular view, but knowing that the structure will be reflected in the systems model. It may actually be more efficient to actually do that work within Maple MBSE rather than trying to build the diagrams.
Okay, that's worth a try.
Yeah.
Okay, so you're, let's say, result driven, because I guess you hide model rules because the model rules are behind in the Excel sheet. So if, as you mentioned, if I like just composition and not aggregation, nobody cares about. It's in the background. It's the Bible of whatever. It's my model rules which are implemented by Excel, connecting to a Teamwork Cloud.
That's right. Yes.
Yeah. Okay.
So I'm sorry, this is the last part I did not really understand. So if I have modeling guidelines in my company, can I add them then to the modeling rules that are now behind this Excel sheet or not?
It depends on the modeling rules. For example, say if it's a modeling practice of naming convention, this is not, you can actually use macros to implement this, but it's not something that's added by Maple MBSE as a default. But say like a modeling rule of how you create an element and the way you create a relation, or for example, say if you add a requirement, you need at least 2 pieces of information, like an ID, name, and say the third one would be, you want to force the user to also add like tag value that's going to say some comment about the requirement. So these kind of modeling rules or restrictions can be applied, but the ones like general on how you create an or how you are going to name a part property or how you are going to name a block, these are not something that Maple MBSE handles.
Mm-hmm. But if I prefer a certain relation, like let's say I prefer include relation between use cases, but I dislike extend, so I can suppress extend using Maplesoft.
Using Maple, yeah, you can do it because in the view, you would already predefine the configuration file. So in the configuration file, if you're only given a exclude, there is no way for the user to add a include relation.
Okay, yeah, perfect. Mm-hmm. Okay.
Thank you very much.
Any other question? Okay, thanks a lot for thanks a lot for
Yeah.
your time, showing a small inside view concerning Maplesoft and the I guess philosophy behind things, which really you speak up my heart, because the barriers and the culture and the people and the training, we face it every day. And I really think about things now. Could you post in the chat the study of Nissan, if you might like it? We will really be pleased if you hand in the presentation, because I would like to publish this in LinkedIn and in our company network, and we'll send it to the participants.
I will do that. Yes.
Yeah. So last but not least, the things I have to say is, I like to present the next webinar. It's a new working group is going to be created, or will be created. There will be a webinar presenting this group on the 15th of April. If you enjoyed the webinar, please recommend us to friends. All the best for you and your SE work, and good night and good luck. Thanks, Paul. Thanks, Barani.
Thank you.
See
Thank
you
you.
next time.
Thank you, Christian.
Yeah, I am
Thanks,
sure
man.
we are getting in touch, because it looks very interesting to me. Okay.
Okay, great.
Sure.
Thank you.
See you.
Thanks a lot.
Bye-bye.
Bye now.
Thank you very much. Bye-bye.